Okay, welcome back to part two of Digital Media Files 101. If you're still here, you're pretty tough. This is some technical stuff. We're going to go on to a little bit more details and specifics of digital media files and kind of how we work with them in typical studio, the kind of files that are used. Okay? So when we paused here, we were talking, about digital media files. We said they're a particular kind of a binary file and they're not human readable. For a computer scientist, that's about enough. Maybe. It doesn't sound too good, but I want to just make a distinction that unless we're, kind of working with these files day in and day out, we're not digging into them. We're not computer scientists. We're just interested in these files because they're the stuff that we are handed that we have to work with, right, to do our jobs. Our jobs are about creating the digital future, right? Not about computer science. So this is kind of like a guy says to you, here's a car, I got a vehicle for you. And you say, okay, I'll take it. And then you find out that it's got a clutch and you don't know how to drive a vehicle with a clutch. So what kind of questions do you ask before you take the vehicle? What kind of questions do you ask before you take the file? So we were talking about media files in part one. Now let's dig in a little deeper. We talked about file types, and so here's some kind of file types. And here's some we work with, right? AIFF audio files, WAVE audio files, QuickTime files, AVI files, audio video interleave files, MXF file, media exchange format. That's a SMPTE standard. GXF format, another SMPTE standard file format. OMF, a format used by AVID. Open Media Framework, what it stands for. MPEG file, motion picture experts group files, video files, right? MPEG 1, MPEG 2. Audio file, MP3, it's an MPEG 1 layer 3 audio file. MPEG 4, Windows Media, and on and on. File types, file extensions. So these are kind of some media files. I'm sure you know a bunch more. So here's a couple of specific audio files, audio file extensions, probably more specifically, but regardless, MP3 audio files used on kind of open source audio players. Windows Media audio files used on Windows Media audio players. WAVE file, that's a wrapper for audio files. Somebody gives you a WAVE file, you want to ask all the kind of codec questions we talked about in part one. AIFF audio interleave file, AU sound, OGG Vorbis file. So a bunch of different audio file formats. Somebody says, I got a file for you, audio file for you. Well, what format? Okay, you might hear one of these. You might dig in and ask further questions like we talked about in part one. So what's the data rate, the sample rate, etc. For a WAVE file, that's a wrapper file, doesn't talk about codec. What codec? Windows Media audio file, what codec? Oh, video files. So a bunch of different video files, QuickTime files, and like we said, we'll want to ask what codec is used. AVI files, we'll also want to ask what codec is used, want to know, ask all the typical questions. And then for some of the SMPTE standard files and MXF files, there's a ton of questions, and you can go Google MXF and SMPTE MXF. If you have access to the SMPTE standards, there's dozens of them related to these files. GXF files from Grass Valley, a file similar to MXF, but just created for a specific purpose, but also standardized. There's broadcast BXF, broadcast exchange format. There's open media framework and MPEG frameworks. Then there's video files that end up in a tar file that are a whole bunch of files all packaged together. There's Cable Labs package. There's a whole bunch of file packaging that can be involved. So a guy says to you, I got a video file for you. You want to ask some questions. file world. So this is how this kind of started. A guy who was real comfortable in the traditional video space says, "Hey, Rob, you live in file world too. We got to talk about that world. That's what the world's becoming." Well, that's what the world has become anyway already. In file world, we could talk about how many files we store, we manage, we move around, and let's look at that. Let's look at where they're stored. Well, they used to be stored on removable platters and disk drives. The first IBM PC had a 5 megabyte disk drive. There was a 1 gigabyte Apple disk drive. My first 1 gigabyte drive weighed 72 pounds. Drives used to be real big. They keep getting smaller. They'll continue to get smaller. SATA drives have gone up recently. I believe there's 8 terabyte. I just saw an advertisement from HGST, Western Digital, maybe, that there's 10 terabyte drive about to be announced, single small hard drive. Fiber channel RAID drives. Their files are stored on RAID drives, RAID subsystems, on file servers, on storage area networks. Files are stored, though, on hard disks. Files are stored on data tape. Right? This is an old slide set, I realize, and so LTO has gone from LTO 4 to 5 to 6. 7 is announced. Just quickly, though, historically, data tape used to be reel-to-reel, 1600 bits per inch data tape. That's what I used in school. And then it got denser, and then it got put into cartridges of DAT tapes and 8mm tape. They're all gone now, pretty much. And digital linear tape is in use still. IBM had its own format, SAIT. And then the LTO formats that we use now. Files are stored on tape. Files are stored on removable disks or flash. And those removable disks have gotten bigger and bigger. Right, from the original floppy disks, the CD-ROMs and DVDs and Blu-rays. And there's now, Sony has an optical disc array that has 10 Blu-ray discs together in changers. There's various hard drives, and a recent interesting development is holographic storage, where the data is stored on multiple layers on a 5.25-inch removable disk. Real dense, not so fast. Files are stored everywhere. So when you talk about storage, you want to talk about how many files you can store. How big are the files? How much does storage cost? Every year it gets cheaper and cheaper. 16 gig chips are no longer relevant, right? Disks are, chips are in hundreds of gigs. You can go buy a little removable thumb drive now for a few bucks that stores all your songs. You want to look at how many files you can store per dollar. My first 1 gig of RAM that I bought for a computer was $75,000. Today, a gig of RAM is less than $1. Storage costs have gone down in that 10-year period that I was talking about here, 75,000 to 1. They've gone down in the most recent 10 years another 75,000 to 1. Storage is essentially free. It's just on this ever approaching free path. It doesn't become completely free, but it's just getting cheaper and cheaper every year. Now, the point here is you can store every bit of music you ever liked, and every movie you liked, every home movie, every photograph you ever took on something that you can hold in your pocket. And all that stuff now you store in the cloud. You just take for advantage. You just kind of take it for granted that it's there. Storage is cheap, free, almost, right? Look at files again, a little deeper, okay? We'll go into some specifics about the stuff that we use in the studios. So when you get a QuickTime file, you want to know the codec. You want to know about the pixels, how big they are. You want to know if they're square. You want to know if it's old-fashioned video where the pixels weren't square. You want to know data rate. Same thing for the audio. You want to know data rate, bit depth, sample rate. You want to know how many tracks, how many channels of audio per track. You want to know if there's time code for audio, for video, right? In all these files. You want to ask all the questions. Windows movie files, you want to ask the same questions. What's the video codec? How big are the pixels? Are they square? What's the data rate? What's the audio codec used in the file? What's the bit depth and sample rate there? Every question that you ask is going to improve your success rate in being able to work with that file. If you're working with MXF files, there's a lot of deeper questions to ask, and that's the subject for another tutorial. MXF is standardized by the SMPTE, the Society of Motion Picture and Television Engineers, and there's just a wealth of information. Let's talk about digitizing. Let's talk about getting stuff from the analog world into the digital world, getting stuff onto the computer. Right? When you digitize audio, you'll want to know sample rate, time slices, how many samples are you going to take in time. You'll want to know about things in a little deeper geek kind of tutorial about the Nyquist limit. How many samples do I really need to take to represent the audio? You want to know how many steps you're going to allow. You want to know what the bit depth is. You'll want to know how smooth you can reconstruct that analog curve in your digital samples. When you digitize video, you'll have the same questions, but now they're in 2 dimensions. You'll want to take a grid. You want to know how big that grid is. You want to know how many rows and columns, and you'll want to sample that grid. You'll want to make discrete steps. In the file world, how are files used at the studio? How are all these files used at the studio, typical studio? Well, avid editing, right? And that's a subject for another tutorial, but in editing. Take these files, bring them into the computer, edit them, reconstruct them, slice them, dice them, chop them up, and put them out, put them on broadcast. We edit with Avid, we edit with Final Cut Pro. So similar applications, take that stuff off of the analog world, off of the videotape, the moving world, bring it into the computer, slice it and dice it, and cut it up and deliver it. Subject for another tutorial. Autodesk Flame, used over the years in real high-end video. Allows video in and out, allows you to create computer graphics, allows you to then take that computer graphics, combine it with the video, and put it out in the real world. Again, subject for another tutorial. So, we talk about audio again a little bit further. We still use linear audio, but we do non-linear audio editing just like we do video editing with applications like Pro Tools. Pro Tools will use a storage area network. Let all those files that you're making be accessible by all the other Pro Tools systems. In the future, we'll talk about video servers. We'll talk about disk recorders. We'll talk about local area networks, software file shares. We'll talk about storage area networks. We'll talk about hierarchical storage management, taking that data that's on the disks, putting them out on and off a tape automatically. A little overview. For further information, there's lots of organizations that deal with digital media files. Here's a few listed. For further information about codecs, go to 4cc.org. It'll tell you all that you ever wanted to know about encoding and decoding audio and video. For further information about viewers, there's a couple of them here that are used to let you inspect some of these digital files that we're talking about, let you learn a little bit more. There's just a wealth of information from each of these sources. Right. After you're done with that, go ahead and search up these couple terms on Google, Wikipedia. and enjoy the journey. Thanks for watching the video. If you like it, give us a like or subscribe, and we'll see you in the next tutorial.